Alright, let's try this again. Let's do take 3 this time. No, is it take 4? I've forgotten now. Anyway, I keep screwing some stuff up, which is getting a little old, and I'm driving me bonkers, to be quite honest with you. Okay? So what I was going to do is an Anova by hand. So again, if you're on a deserted island somewhere and you're like, I got to do some statistics. I question your sanity. You're on a deserted island. You should start working on your base 10, all over 10. You should build yourself a hammock. You should start fishing. Okay, get your priorities straight, for goodness sakes. But if you had to, here's what you would do. So the degrees of freedom, okay, for the factor, or for between columns, is the number of columns k minus 1. So 3 minus 1 is 2 degrees of freedom. For error, it is the total number of individuals. In this case, there are 9 data points minus the number of columns, which is 3. 9 minus 3 is 6. And the total degrees of freedom is n minus 1, which is 8. So what you do is you're going to want to find the means of each of these columns, which I did. And I found the overall mean. Now to find the sum of squares total, okay, you're going to take each individual item and subtract the grand mean from it, like this. And then 2 minus 3.88 squared, and so forth and so on, all the way through 9 times for all 9 of them. Now, this, as I say, this is about the 19th time I've done this problem, and I keep screwing some stupid little thing up. So I'm going to do it the easy way with this, but if I had to do it with the calculator, I feel confident I probably could do it with the calculator, but apparently I've screwed it up twice today at least, so I'm not real happy about it. So what I'm going to do is I'm just going to use Excel to just help me make sure I get the numbers correct, if you don't mind, and then drag it across like so, and now I'm going to find the sum of that. So the sum of these 9 numbers is 20.88. That is my total, oopsie daisy somewhere, nope, that's what I wanted. That's my total sum of squares. So when we go to find this, we're going to keep that in mind. In other words, it is, if you take each individual and find its difference from the mean and square it, if you think about it, that is exactly what we did when we found variance back in, I don't know, 243, but like in chapter 3 or somewhere. We found the variance by finding each number, subtract the mean off it, and square it. That's kind of how we went about finding the variance, hence the name analysis of variance. Now to find the analysis, to find the sum of squares for error, that is within group, we're going to take each value and subtract off the mean of the column that it's in. So that top row here, this top row refers to the first column, and then the second column, the third column. And I add those all together, and I get 6.003. Now, in fact, because these are rounded off to 0.33 and 0.66 and all that, I think this should be exactly 6, we're going to see pretty soon. Okay, so what I've gone here is I've gone ahead and made a sum of squares table, an ANOVA table, and I filled it in. So here's my total sum of squares. Here's my degrees of freedom. Okay, here's my sum of squares for error. I went ahead and rounded it off to 6. Okay, the degrees of freedom is 6, so the mean square is just simply the sum of squares divided by the degrees of freedom. So there's that. Okay, oh, this is the wrong number here. One more thing that's wrong. There we go. Fixed it. All right, now let's, how do we find this sum of squares for factor? Well, it is exactly what you think. It's this guy plus 6 equals 20. That means the factor must be the difference, so 14.88. And then 14.88 divided by 2 is 7.44. And my F statistic is 7.44 divided by 1, which of course is 7.44. And then if I grab my calculator to find a p-value, I would just go into apps and go to stats list editor, and I would go to the F statistic, so FCDF, and I would plug in 7.44 for my lower bound, 7.44 to infinity, with 2 and 6 degrees of freedom, that's correct, and I get a p-value of 0.0238. Booyah. And if we've done our cards right, if everything works out well for this deal, if I came back into here and said, hey, let's just go do a single factor ANOVA. What? Look at that. Boom, 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 boom. Wow. Anyway, that's where the numbers come from in case you were ever wanted to know. Again, I don't remember the last time I felt the need to do one of these guys by hand. I know I've done them with a computer many times. Yeah, I don't think I ever cared to do it by hand again in my whole life. And by the way, this was only with 9 total numbers. What if you had, I don't know, 17 or 20 in each column? Good luck with that.